is a video. This could be for any Algebra 1, Algebra 2 class. Who cares? It's if you need help factoring trinomials. And it's factoring trinomials where this number, that coefficient, is greater than 1. That's always a little bit more tricky. Okay, so I have just learned this method. It's called the Lizzie method, and I love it. But what you do here is, first of all, whenever you factor, you always look to see if there's something that all three terms have in common. And if there is, you need to pull it out. This one does not. And we'll do one here in a little minute that does. But here's what you do. You always take the first times the last. It's called, I used to call this the AC method because it's very similar. So you're going to take 3, and this is not just a 5, it's a negative 5. So you're going to take 3 times negative 5, which is a negative 15. So what you want to do is find factors of negative 15. That means things that multiply together to give you negative 15 that add up to negative 2. So first of all, let's just think of some factors of 15. Okay? Now I want it to be a negative 15, so one of them has to be negative. So notice both of these multiply to give you negative 15. Now I want one that adds to a negative 2. Now notice this one. It adds to a positive 2, so what I can do is just change the signs of both. So once again, notice this multiplies together to give me negative 15, but it adds together to give me negative 2. So this is my magic pair that I need right here. So what you're going to do is whatever this number is right here, and ignore that exponent just for a minute, but we're going to write 3p over 3, pick this number, and we're going to write 3p over, that's a negative 5. Okay? Now, if it will reduce, do it. Notice these 3's will each go into each other one time. 3 goes into 3 once, 3 goes into 3 once. This will not reduce. So what I'm left with is a 1p, and that is a positive 1. So I'd write it like that. In this set of parentheses, I have a 3p, and that would be a minus 5. And that would factor it for you. And you're like, does it really work? Yeah, try it out. Look, here, this gives me 3p squared, which is what I had. This gives me a negative 5p. I'm just checking my answer right here. This gives me a 3p. Notice when I add that together, I get my negative 2p. And when I multiply my last terms together, I get a negative 5. So that's pretty cool. So this right here would be when I factor out that trinomial. Okay, let's try another one right here. So remember, first of all, you look. Do my three terms have anything in common that I can factor out? No, they don't. So I'm just going to take the first times the last. Make sure you're watching that sign. That's 2 times a negative 9, which is a negative 18. Okay, so we're going to find all these things that multiply together to give me 18. Because it's negative, one of them has to be negative. So I just kind of do it like that. Now, I'm looking for the magic pair that adds up to 3. Do you see any of these that add up to 3? And I'm like, hey, this one does. Negative 3 plus 6 is 3. So this is my magic pair. That's what I want to pick. So I'm going to take this 2n, remember, ignore your exponent, 2n over negative 3, and I'm going to do a 2n over 6. Now this fraction does not reduce, so you can't do anything with it, but this fraction does. Look, 2 will go into 2 once, and 2 will go into 6 3 times. So that one will reduce. So I am done. In one set of parentheses, I'm going to have a 2n minus 3. And in my other set of parentheses, I'm going to have a 1n plus 3. Okay, it's a positive 3. Notice this is a positive 3. This was a minus 3 because this is a negative 3. So it works like that. If you would multiply all this out, notice you would get back exactly what you started with. You would get a 2n squared, cool beans. Here you would get, what, a 6n minus 3n, which is 3n. And negative 3 times 3 is a negative 9. So that works. Okay, we're going to do another one. Again, we're going to look to make sure that nothing factors out, and it doesn't. So I'm going to take the first times the last. Well, let's see here. That's 3 times a 4. That's a positive 12. So I'm thinking of all the factors of 12. There they are. But I want the ones that add up to a negative 8. Well, I notice this one adds up to 8, but I need it to be a negative 8. So what I'm going to have to do is make them both negative. Okay, because notice when I multiply these together, negative 2 times a negative 6 is positive 12. Negative 2 plus a negative 6 is a negative 8. So this would be my magic pair right there. So again, I'm going to take whatever this first term is, ignore the exponent for now. we're going to take a 3n over a negative 2, and we'll take a 3n over a negative 6. Notice this one doesn't reduce at all, so in my first set of parentheses I just have 3n minus 2. But this parenthesis does reduce because 3 will go into 6 twice. So I'm going to have a 1n minus 2. And that's it. Okay? Now, real quick, I'm going to look through here and see if I find one that there's something common that will factor out. I'll flip this over. Well, I don't see one yet right here. I'll make one up here in just a minute. Let's do one more. This one looks a little bit more difficult. I'm going to take 5 times 12, which is 60. So let's think of the factors of 60 that add up to 19. And I'll just tell you real quick, I'm thinking 10 and 6, but that adds up to 16, so that doesn't work. How about 15 times 4? That would give me 60, okay? And it adds up to 19. So this is my magic pair. So I'm going to take 5n over 15. It doesn't matter what order you go in. I'm going to take my 5n over my 4. Now, that one doesn't reduce at all, so I can't do anything with it. So go ahead, and it can go in one set of parentheses. It's a positive 4, so it's going to be a plus 4. This one, though, 5 will go into 15 3 times. So I'm left with an n plus 3. Okay, so there's your answer when you factor out. I just love it because it makes things so easy. Okay, I'm going to make one up here, so hang steady. Okay, look if I had this one right here. Notice the first thing I do, that a 3 would go into all of these, so I am going to do the opposite of the distribution property, and I'm going to pull a 3 out of all of these. You have to show out front what you're pulling out. So notice this is going to be a 2n squared, because 3 times 2 is what would give me 6. This would have to be a 5n, because 3 times 5n is what would give me a 15n, plus 2. You can see I kind of just stole it from right there, okay? You have to be sure that if you multiply this 3 back in, you get exactly what you would have started with, okay? Now, because this isn't a 1, I'm going to do my little Lizzie AC method. So I'm going to do the first times the last. 2 times 2 is 4. So I'm looking for factors of 4. There they are. That add up to 5. This would be my magic one right there. So I'm going to take this right here, 2n, put it over the 1, and I'm going to take a 2n and put it over the 4. This one does not reduce at all. Can't do anything with it. So go ahead, and we're going to put it in one set of parentheses. This one, 2, will go into 4 twice. So I'm left with an n plus 2. What you got to be sure and remember to do is remember at the beginning when you factored out this 3, you've got to make sure you pull out that 3 again. Okay? Won't work. All right, let's try another one. Let me see here. I'm making one up here. There we go. Hopefully this one will factor. Do you see anything that you can factor out of all 3 of these terms? And first of all, I don't even like that the first term is negative. So no matter what, I'm going to pull out a negative. I do notice that they're all even, so I'm going to pull out a negative 2. So be real careful here and watch your signs. Negative 2 times 2, b squared. Will that give me back exactly what I started with? Yes. Okay, this is going to have to be 2 will go into 22 11 times. Notice I changed that sign because a negative 2 times a positive 11 is going to give me that negative 22. Plus, let's see, 2 times 5 is going to give me the 10. Okay, now this isn't a 1, so I'm going to do that Lizzie AC method. So I'm going to take this, 2 times 5 is 10, and good grief, I need to find factors of 10 that add up to 11. And the very first ones I tried, there they are. So I'm going to use 1 and 10. So I'm going to take this 2v over 1 and 2v over 10. Okay, this won't reduce, so I have 2v plus 1 in one set of parentheses. This will reduce. 2 will go into there 5 times, so I'm left with v plus 5. Do not forget, at the very beginning, you pulled out that negative 2. It has to still sit out front. Otherwise, when you multiply this all back together, you wouldn't get back what you started with. So hopefully that will help you when you're factoring trinomials.